Find the answers to questions you may or may not have asked yourself. Here at Kaleidoscience, Conversations on Cognitive Science. I think all of us have experienced pain at a certain time of our life. So we might have stepped on something that hurt us, or we might have burned our hand, or fall from a tree as a child and hurt our arm, broke our arm, whatever. So we know, I think all of us know how it feels to have pain. And I think all of us also know how it feels to see other people experiencing pain. So seeing someone in pain and then feeling something towards that. And today we are talking to Helena Hartmann, who is a postdoc at the University Hospital of Essen and is researching exactly that. So she's researching on what happens in our brain when we experience pain, but also what happens when we see other people experiencing pain. And I'm really looking forward to this interview today, also because Helena's already quite experienced in science communication. She's also doing one project, which I think is pretty cool. It's a website or blog. I'm not sure if it's rather blog or website, but it's called Science and Fiction, where you can read science fiction stories about science. And I really like that idea. So welcome, and I'm looking forward to talking to you today.
Thank you. I'm excited for the interview.
Okay, then we're going to start with a little get-to-know game. So I would like to ask you to just spontaneously complete these 5 sentences. So as a kid, I always wanted to be.
I think I wanted to be a translator when I was really young. So translating English to German. Obviously not when I was really, really young, but once I started learning English in school, it fascinated me a lot. So that's what I wanted to do.
That's really
Was it
cool.
only English specific, or was it also other languages?
Yeah, I mean, no, only English.
Okay.
Yeah. Okay, the second sentence is, if I was an emoji, I would be.
So I think the emoji I use the most is the one with the little teardrop on the side. It's more like, it's not embarrassed, but it's like, yeah, that's how it is, or that's how the situation is. It's more like this, I think that's my emoji.
Okay, and my favorite thing to do on a day off is?
Read and stay at home.
More like scientific literature, or more like...
Oh no, far from it.
Like
Science fiction, dystopian stories, anything that is not related to science.
That's really cool. And the fourth sentence is, right now I'm most fascinated by?
Placebo effects. So the fact that people can feel an improvement through a treatment that is in essence sham or inactive.
And I know it's time to call it a day when?
My concentration drops. That's usually sadly already after lunch most days, but I try to keep going until the afternoon. But I notice quite quickly when my concentration goes down, and then it's time to call it a day.
Okay.
Are you more of an early bird that's just getting tired in the afternoon? And so,
I wish.
you really... Okay.
I think I'm neither. I'm like, it's a bit hard to get out of bed in the morning and also in the afternoon. Yeah, I think my most productive hours are probably like 9 to 2.
But it's pretty similar for me as well. Like after 2, I just want to sleep and have a lot of coffee.
For me, there's usually like a little dip in the afternoon, and then later it gets better again somehow. Okay, so can you tell us a little more about your scientific background and how you became a pain researcher?
Yes. So, I mean, we talked about what I wanted to do when I was a kid, which was a translator, but actually when I started studying, which was psychology, what I wanted to do is become a therapist, like many people who study psychology. So I wanted to finish my studies, then do the therapy training, and then become a psychotherapist. And during my studies, I got more and more interested in science and the scientific process itself. So I did a lot of internships. And also for my master thesis, I did a quite intense, for a master student, elaborate study, which was a huge neuroimaging study where I measured brain activity in lots of people with and without autism spectrum disorder. So the whole process of the study, from recruiting, collecting data, analyzing, and publishing, I think that's what got me interested in science in the first place, because you're still like a super newbie to the field. So you have a lot of people guiding you, and you feel very, at least I felt I had very good supervision and mentoring at that time. So I think that's also a big bonus, that if you have the right people to mentor you, that might get you more interested. I think my mentors definitely also played a big role. And after my master, I kind of thought that was an interesting idea. And then I was really lucky because my then PhD supervisor was looking for somebody to apply for a scholarship with. So I gave it a try. It could have not worked, right? And I actually don't know where I would have ended up if I hadn't gotten the scholarship, but I did. And so for the next 4 years, I was doing my PhD at the University of Vienna. And then I think after the PhD, you kind of hooked because you're just starting in science. You're just starting to publish, and you kind of finally know what everybody's doing, and you have a rough idea of what you're doing. And it's very hard to stop. So I think that's the phase I am in now. Like, I'm really enjoying what I'm doing. I have a lot of freedom, and I can, now I can also research things that I'm interested in. While during the PhD, sometimes you're still guided with what other people or maybe your supervisor wants to research, and you're hoping for some guidance there. But now it's very freeing and very nice and very flexible. So I think that's what's keeping me right now.
That sounds very cool.
Yeah. What are you currently doing in your day-to-day, like, researcher's life? What is your, like you mentioned that you have a job in the afternoon, but how does your usual day look like?
I think it's very unglamorous as to what media portrays scientists do. So I have a white lab coat. I wear it sometimes because I work at a hospital. So when we do experiments, we wear lab coats. But usually I just sit in my normal clothes at the computer and do things, lots of things, like reading new literature or looking at data I collected, trying to figure out how I can plot a certain part of my data in a nice figure. That takes, for some reason, intense amount of times. And writing papers in the end, right? So, and then actually, let me rephrase that. The majority of my workday is meetings with other people, because I do a lot of projects and they all have to be, happening at the same time. So meetings is my way of time boxing it a little bit. So I have a lot of meetings with people that are sometimes more or less productive.
How many projects do you have at a time? I'm just curious.
Too many is what is the answer that every researcher will give you if you ask them, because we tend to, I'm speaking for myself, I tend to be very excited about shiny new projects that promise to be super cool, and then some of the ongoing projects kind of take longer than anticipated and get stuck, and so it's many different things at the same time. So I don't know if I can count them, but I have kind of my major postdoc projects that my supervisor wants me to do. I have some data from my PhD that I still need to publish and finish up. So that's kind of going on in the background. I also did a broad research stay in Amsterdam where I collected some data that is also still lying around. And then I have things that I want to do that I just started randomly new. So it's a lot.
Sounds interesting, but also very intense.
Yeah, I think the key is very good time management. I often, make commitments very far ahead so I can plan them, and I'm usually quite good at that. Sometimes it gets a bit much, but I'm still learning, so hopefully I will improve at some point.
So let's go into the topic of pain research. So how do we perceive pain, and what happens in our brain when we are in pain?
Could you maybe also shortly go into what pain is? So, like, in just a couple of terms, what is pain? Well,
Yeah.
I think all know what it is, but what is it?
Well, I think we can define it as a subjective experience. So that is something that we feel or how we interpret the feeling. Um, and we have to distinguish between pain and nociception. So nociception is what our nociceptors, so the cells in our hand, let's say, perceive when we put our hand on a hot plate or something like that. And that gets transmitted through the arm, through the body, through the spinal cord to the brain. And pain is how we interpret what happens, what is brought to the brain, right? So what comes out basically. So it's not linear at all. It changes. It is very malleable and flexible. It can be dependent on the person, on the time of day, on the context, on their mood, the age, disease, basically anything. And that makes it actually a really fascinating, but also really hard thing to study. And if we look at how pain is processed in the brain, that's already quite well researched. So usually people divide pain processing in two components. One is called the sensory discriminative component. That just means the basic physical characteristics of pain. So, is it in my right elbow? Is it stabbing or is it dull? How long does it take? So, these basic characteristics are processed by this component. And that is, for example, that recruits the somatosensory cortex. And then on the other side, there's the so-called affective motivational component, and that's more the emotional subjective part I was talking about. So this part is responsible for processing how unpleasant the feeling is and whether we want to remove ourselves from it. So it is more this subjective judgment of pain. And that, for example, recruits regions like the anterior insula, that is really deep in the brain on the side behind the ear, or the cingulate cortex, which is in the middle of the brain. And those regions, as with many regions in the brain, do a lot of things, but those kind of always light up when we give people pain. So in earlier times, this network of regions was actually termed the pain matrix. Which sounds very futuristic. Now people are going a bit away from that, I think, and more thinking of it in terms of components or networks.
Is are all kinds of pain activating the same parts of the brain, or is it dependent on where you experience the pain?
So there's a lot of research and a lot of debate going on when the different types of pain are processed similarly. And if you use functional magnetic resonance imaging to do that, what you typically get from the normal analysis one could do with that is which regions light up or are active when you get a certain pain. And here people find a lot of overlap. So that means that if you feel physical pain, like stepping on a Lego stone, versus you think about a situation where you had a so-called social pain. So, for example, a rejection by a partner or a breakup or something like that, or also being excluded from something. So there's lots of studies showing that there's overlap. So the same regions are active in both situations of pain. And that's quite interesting because that led researchers to hypothesize that maybe we process these different types of pain similarly in the brain. And then there's the other types of, there's other researchers coming in and being like, no, 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 no. Just because the region lights up in both situations doesn't mean that the same exact neurons in the brain are active for both types of pain. So it could be that for physical pain, a certain combination, a certain pattern of activation is, going. And for the other pain type, it's a completely different neuron population. And so there are some approaches, so-called multivariate pattern analysis, where you look not only at activation in general, but you look at patterns of activation, like, more parts of the brain being active at the same time. And there people find that this is actually quite different between types of pain. So it's still, I would say, an ongoing debate, and we are having more and more fancy techniques to try to get closer to what is really happening. But the final word has not been spoken.
And you've also mentioned that every person experiences pain differently and also depending on the day. So how does it work in actual pain research then? Because like, how do you control that a certain pain stimulant does what it's supposed to do or what it's supposed to feel like for the participant?
Yeah, so in the first instance, it's a complete mess, because how are you going to measure pain that changes all the time and is so fleeting and is so subject to external influence or even internal influences that we cannot control? So what we as researchers try to do is we try to control as much as possible. And we do that by inviting, for example, only a certain type of people. That could be people of the same age, or at least age bracket, let's say 18 to 40 years old. Um, we invite and test people at the same time of the day, so not have some people in the early morning and some people in the evening. We make sure that, especially in terms of if you do pain experiments, that they don't take any pain medication before they arrive, that they are well rested, haven't drunk any alcohol or taken any drugs the hours before. And sometimes we even limit what they eat and drink before. And that is especially relevant when we give medication, also when we do pharmacological studies. And then let's say all of these criteria are as homogeneous as possible. We try to keep it all the same. Then we can control the way the experiment is run. So we can apply in pain research, we use electrodes or thermodes. That's just little pieces of equipment we attach to the body part, for example, the arm, to transmit pain in different ways. We put that always at the same location, for example, or we have certain locations we mark that we switch regularly so that the skin doesn't, get too used to it or too sensitive. That's both possible. We explain people very well the scale that we use to measure pain. So usually that's a so-called visual analog scale, where on the one end it says, I don't feel any pain. And on the other end it says, I feel the most pain that I can feel. And we ask people to move the cursor on this dimensional, on the scale. And we explain it very well, what it means, that they can use, the whole extent of the scale. But then even with doing all of these things perfectly, sometimes participants still do things that we don't expect. But that's how it is.
Can you give an example of what is unexpected, for example?
So let's say you applied, let's see if that's not a too complicated example. Let's say you applied cream to the right hand before you gave people pain stimulation, and you told them that on the right hand, you're applying a cream that is actually a local anesthetic, so it will reduce their pain on that hand. And on the left hand, you apply a skin cream that doesn't have any pharmacological ingredients, so the pain should feel normal. So what you would expect is people to rate the pain on the right hand lower than on the left hand. And that is what we call, if they would do that, that is what we call a placebo effect. But of course, you can have people who do not respond to that. So they maybe have very little or no placebo effect at all. And then they rate the pain on both of their hands completely the same. Or even, which is even worse, the opposite. So they rate the one on the right hand where they got the anesthetic higher than on the left. And all we can do is, through questioning and feedback at the end, try to figure out how people perceived pain during the experiment and what potentially went wrong. And sometimes you have also equipment malfunctioning, so that the pain you give maybe doesn't arrive at the participant how you intended to. So these are all things that can mess with your data.
Okay, so let's go a little more into like the practical parts of pain research. how would like a pain experiment look, for example? So you already went into like that there will be like electrodes or thermodes attached, but how would it generally look, or how do you do pain research?
Yeah, so you invite people to come to the lab or to the MR scanner, depending on where I'm testing. Um, if they come to the MR scanner, it's a bit more complicated because you have to make sure that they have no metals in their body and that they can go inside and everything will be fine. So we have a lot of screening and exclusion criteria that we need to take care of beforehand. But then if people make it to the lab or to the MRI scanner and they are inside, what we do is we attach a thermode or an electrode, or both in some cases, if we're feeling very fancy, to the arm or the leg. So with an electrode, you can give electrical pain. That's very short, can be long, but we give quite short bursts of electrical stimulation that feel a bit like a bee sting or a twitch or something. It's over quite fast though. What we can also do is we can apply a thermode, which is a little square, let's say 3 by 3 centimeters, that is applied to the forearm, and that gets warm or even hot. And we can stimulate the person with different temperatures. And you might, I mean, we talked a lot about that people perceive pain differently already. And this is already where it starts. So if you give people, let's say, a temperature of 45 degrees, people rate it completely differently. So what we have to do before we even do any experiment is to do a proper calibration of people's pain. So that means we give them stimulation in varying intensities. We let them rate it, and then we fit a model. So we do some statistical analysis on the ratings that the person just gave to find out, on average, which ratings on the scale belong to which temperatures. And so then we can basically have a specific pain level per person um, that we will use in the experiment. So it could be that if we want to give somebody a painful stimulation that is supposed to be very painful, that for some people it is 45 degrees and for some people it is 50 degrees. That is also that's a possibility, and that's fine because what we want in the end is that the people feel the pain similarly. So we try to calibrate it for every person, and what we put in the machine can be very different, but what hopefully comes out is the same for every person. At least that's the goal.
Yeah, I feel like that also makes sense because I feel like even just general temperature perception between people is so different already.
Yes.
So sometimes you walk in a room and you're like, oh, I'm so cold, and everybody else is like, no, what do you mean?
Yes, and we have also people. So we have a maximum temperature that we do not go over because we don't want to. So usually the skin gets a bit red if people do a pain experiment, right? Because it's just stimulated a lot. We give a lot of stimulations, but we do not want the stimulation to damage the skin in any way. So there is regulations and rules to stop. And sometimes we have people who we give the highest stimulation possible and they think it's okay, and then that's quite hard, right? Because we want to induce pain, but that's kind of the limit, and these people sadly would have to be excluded in the most extreme cases, just because potentially we would not see any activity in the brain in pain regions just because they didn't perceive it as very painful.
I'm just right now thinking about like situations where people don't feel pain as strongly as usual, because I know that when I'm really stressed, I won't notice pain as fast as usual. And I think being in an experiment can already be a stressful situation for participants. So
Oh,
I could just
definitely.
imagine that just being there also changes the perception of pain or heat for
Yeah, and
people.
that is something, you're completely right, and that is something it's very hard to change. Like we have to accept it as experimenters or as researchers. We try to make people feel as comfortable as possible, but I always have some people, especially for the studies in the scanner, that are very nervous. And we have people actually discovering in the scanner that they are not happy lying in a very tight bore for a long in a dark room for longer periods of time, which is completely fine, right? Um, So we try our best. Usually we have some chocolate to bribe people in the middle. But you have to be very aware of this, and you have to make sure people feel like they understand everything, like they're fine with it. And we have to monitor the participant very closely, usually, to make sure that everything is going fine and they're still fine. And usually, and that's quite common, and that's also the ethical thing to do, participants are told in the beginning they have to sign a consent form, whether they agree to participate voluntarily. They can stop the study at any time. They don't even have to tell us why, and there will be no negative consequences. They will be paid, for the time they invested in the study. And I hope, at least in the studies that I did, that was fine to comfort patients or people that they knew they could stop if they wanted. But it is even more relevant. I mean, you don't sign up for a pain study if you're not ready to get some pain. So we do have a selected group of participants who is interested in these studies, I would say. But it is especially important for my studies on empathy, so where I investigate how you perceive the pain of other people, because sometimes you, at least in my experiments, you are also responsible to how much pain the other person will get. And that is very important because that can be quite distressing to people.
You've just mentioned the next word, empathy. And could you maybe quickly explain what empathy is before we go deeper into empathy and pain research and what it has to do with each other?
Yes, of course. So empathy has many definitions. If we try to do it really, easily, we can say it is feeling what somebody else is feeling. So we feel the same emotion than another person that we're observing. But of course, research loves things complex. So they come up with elaborate multi-part definitions. So if we try to define it in the science way, we would say that, first of all, to feel empathy, we have to see or imagine somebody else feeling an emotion. That can be in a video, it can be live, it can also be reading about it. And then we have to share that emotional state. That's also called an isomorphic state. So it means we feel the same or very similar to the other person. But that's not everything, because once we share that, you can imagine that you can become quite distressed from feeling what somebody else is feeling. So in order to feel true empathy, you need to have some regulation mechanisms. That means that your brain has to, or you have to understand that the source of the emotion that we're feeling is coming from the other person and not from ourselves. So this is called self-other distinction. We have to make a distinction between our feelings and the feelings of the other person. And only if we do that, at least in some definitions of empathy, means you can feel true empathy. If you don't do that, what you might feel is something researchers call personal distress, where you feel the emotion, you share it, but you're so overwhelmed by it that it's a very self-centered emotion that results. While empathy is actually a very other-focused emotion, so we're focused on another person. So I thought that was quite interesting. And in my PhD, I was investigating a lot this affect sharing component. So how we share the emotions of other people. There's also the distinction between cognitive empathy and affective empathy sometimes. Other researchers hate it. Some hate it, some love it. So it's a big debate as well. But under affective empathy, we could call this affect sharing component, so feeling what somebody else is feeling, while cognitive empathy could be the cognitive component, understanding or knowing what somebody else is feeling. And that also, I mean, people came up with these two parts because you can understand what somebody else is feeling without necessarily sharing it, or you can share an emotion without necessarily understanding what that emotion is. So they can also kind of, exist separately from each other. But for true full empathy, both are present in some form.
Just for me that I got it right. So empathy is kind of that you are aware, like the main distinction between empathy and just absorbing another person's emotions or status, that you are aware that what you're experiencing or from the other person is not your own, but what the other person might be experiencing. Because I would just, like, my thought while you were explaining was also, when I see one person having a certain emotion, I would kind of feel the emotion like, no, I would not feel it as if it was mine, but I assume how the person might feel. So I make an assumption about how the other person feels, and then kind of experience the emotion connected to my assumption, or the
Yes.
cognitive understanding connected to my own assumption. Is that correct, or would that also be not empathy but something else?
I think we're always doing that to some extent, like, because we never know the true emotion that somebody else might be feeling, right? So if you see somebody crying, you might assume that they're sad, and you have empathy with this sadness. You feel also sad. In other cases, it might not be so clear, but we still have to go with our interpretation of it. I mean, empathy, for the person feeling empathy, is how they view an emotional state in somebody else. So it is about that interpretation in the end. And a very interesting example is if you see somebody crying and you feel really sad, so you empathize with them, and then you ask them why they're crying, and they say, "Oh, I just got a promotion. I'm so happy." That would immediately change your empathy or your emotion that you're sharing, right? But only through that information. So I think that's quite interesting how we're also flexible to change this this state that we are in when we're empathizing.
And can empathizing with another person influence the emotions of the person originally having the emotions?
That's a very good question. Um, I think so. If that person also has empathic abilities or is kind of observing you, because that would be like, I guess, counter empathy. Like, you have empathy with someone, you show an emotion, the other person sees you and reacts to that. So empathy is something that involves two people, and as I mentioned, it's very other focused. So we're focusing on the other person. We're kind of going into an interaction, not necessarily like a conscious one, or you're not necessarily talking, but you are kind of forming something, some connection. And it's interesting because a lot of research nowadays goes in the direction of not only testing one of these two people, but testing both of them and looking at things like brain synchrony. So not only do the emotions synchronize, but maybe also activity in the brain or certain other physiological parameters that we can measure may synchronize or adapt if we are in interaction with another person. So I think that's super interesting.
Does it does it rather downregulate when you notice someone experiencing empathy, or does your own emotion increase?
Yeah, I think it's quite variable. It can vary depending on the person. And as I said, there's many steps necessary to feel empathy. And at any point, you could stop and not reach this empathic state at the end. So, for example, there's a famous example of in a hospital, lots of babies are born, they're all lying in the same room. When one baby starts crying, the other babies start crying. That is not empathy because it's not a conscious sharing of somebody else's state. It's what we call emotional contagion. So just this first basic, very unconscious automatic step happening of just feeling what somebody else is feeling, which is just they're being, it's contagious. So the other babies also start crying. And then later, if you, let's say you're a bit older and you hear somebody crying and you feel that emotion and you understand, oh, maybe it's because something happened, or, I can understand that because I had a similar experience, is more this cognitive evaluation of the other's emotion. So I think there's many different routes you can take when you perceive an emotion. And what comes out at the end is in part also a lot dependent on how you are and how you perceive other people.
And bringing that back onto pain. So what has pain to do with empathy or empathy with pain?
So when we investigate empathy, pain is a very nice model to do that for several reasons. First of all, pain is a very prominent and salient emotion. We can induce it very easily and robustly in experiments. That means that if we give someone an electric shock, it will most of the time always feel painful to the person. It may be in different levels and it may depend on certain things, but it will be painful. So it's something that we can induce quite well in experiments. And the other reason is that we already talked a lot about the brain regions and networks involved in pain processing. So that, because that is already quite well researched, gives us a very good basis to try to understand what goes on, not when we feel pain ourselves, because we know what's going on in the brain during that, but what happens when we empathize with someone in pain. So I think that is where a lot of social neuroscience research has gone. There's also some niche research on positive empathy. So, feeling happy emotions for somebody, but quite rare. And I think we need more of that because we do a lot of research in the pain field, at least I do. And the question is always whether it is generalizable to other emotions. So, the findings that we generate in pain, can those be transferred to empathizing in other ways or with other emotions of people? That's always the question.
And when you do a pain experiment and somebody sees another person in pain, does something similar like pain happen in their brain or something completely different? Or
Yeah, that is so the answer to that is one of the reasons I think why I was also so fascinated with this research in my PhD, because before I started my PhD, there had been some experiments at my lab in Vienna, the lab of my supervisor there. And they wanted to see how similar feeling pain yourself and seeing pain in other people really are in the brain. And their theory was very clever, I think. So they thought if these two processes, so self pain and other pain, are really processed by the same parts of the brain, so the same regions light up, then if we interfere with one of these processes, it should automatically also change the other. So what they did is they used placebo analgesia. That is a very fancy word for reducing people's pain using sugar pills. So you give people a pill, you tell them it's a painkiller. It is you can do that with a real painkiller as well, but in that case, it's a placebo, and you induce a placebo effect. So people feel less pain because of this placebo they have taken. And that happens because thinking you have taken something that will reduce your pain activates the body's endogenous opioid system. That is a system that releases neurotransmitters, for example, endorphins, and those are responsible for causing analgesia, so feeling less pain. So that happens with real painkillers, but also with placebos. And so what they did is they gave people this pill, they presented it as a painkiller, and then people had a placebo effect. That means they felt less pain. But now comes the interesting part. They wanted to see whether that would transfer to their empathy. And so what they did is they not only gave the people shocks on their own hands to see if they had placebo effects, but they also gave shocks to another person sitting next to the participant. And then the participant rated their own pain, but also the pain that they thought the other person was feeling and how unpleasant it made themselves feel watching this other person get pain. And the very fascinating result was that in both cases, they found an effect. So they found that people felt less pain themselves, and they also had less empathy for other people in pain when they had taken this placebo painkiller compared to a control group who did not get any pill. So they felt, normal levels of pain themselves and normal, let's say, high levels of empathy, because what is normal? We can go into a complete new discussion there. But the people in the group who had gotten the pill reduced both their own pain and their empathic pain. And that was first evidence that maybe, in fact, we base our empathic understanding of other people's pain on areas in the brain that are also relevant when we feel pain ourselves. So we can give an example. If I hit my elbow on the door frame, certain areas in my brain will light up. They will be active, processing that pain. And those very same regions also light up when I see Elisa or Sophie hitting their elbows on the door frames. So I thought that was super fascinating, that there seems to be some evidence that both processes, self-pain and empathy for pain, are processed similarly. And this whole theory is called shared representations theory, because it's a sharing of the same representations in the brain for both of these processes.
If I'm not mistaken, if we imagine being in pain, so if you would imagine in this example hitting your elbow on the door frame, would also the same areas in your brain light up? Because then kind of seeing another person, me or Sophie, for example, hitting our elbows on the door frame, would that, well, I think my question is, does the empathy part, yeah, no, it does connect.
Yeah,
I think
it's
my
the
brain
same.
answered my question. Yeah, I think it's this imagining the pain of the other person. Yeah, it makes sense.
Yeah, and the fascinating thing was, in the experiment, the pain was quite abstract. So our example now was that I see you hitting your elbow. That's quite graphic, right? But in the experiment, people were lying in the MR scanner, so they didn't see anything. They just got a little hint on the screen that now the other person is getting a shock. Now you're getting a shock. Now the other person again. So they actually needed to imagine that the other person was now getting a shock without ever seeing these people. I think what they did, they showed videos of facial expressions just to underline that the other person is now getting a shock and it's painful. But in many experiments, it's actually quite difficult to empathize. So sometimes I wonder how people can do that, but they do. And that's a nice finding.
I have one more question about this research, because basically, when they experience less pain, they are also less empathetic to other people's pain, right?
Yes.
Would that mean that, for example, people who experience less pain in their like generally, so for example, I'm not that sensitive to heat, so if I'm less sensitive to touching like a hot cup, would I also be empathizing less to you holding that hot cup, even though for you it's very painful?
That's a super good question, to which I don't have an immediate answer to. I think it's very interesting. And what I know is that people have studied populations that feel literally no pain. So there's so they have congenital insensitivity to pain. That means they are born without feeling physical pain. Um, and of course, the question comes up whether these people are able to feel empathy if they don't have any self experiences of pain. And here we come back to the two components of empathy, cognitive and affective. So it turns out people can very well share the emotion of somebody else on a, subjective level, even if they have never had pain experiences. And so that you could think that is a bit in contrast to this theory, right? Because if we need our pain experiences, now it works without them. But I think that is why we are still having jobs and looking at these things, because it's not clear, and sometimes you have conflicting results. And I think it's a lot of questions that are still unanswered. Another example is and that's something I did in my PhD, if you give people painkillers, or you tell them, you give them painkillers, would they also feel less empathy? In the studies that were happening before I started, that was the case. And for example, I wanted to know if taking a painkiller would not only influence how you empathize, so your feelings, but might also influence how you act towards someone else. So whether you help them, for example. And I found that people who took a painkiller, in my case, it was also a placebo painkiller, but it works the same way. People who took a painkiller felt less pain. That led them to feel less empathy for the other person. And that led them to be less helpful, to avoid pain of that person going forward. So I thought that was very interesting that we have this connection between what we feel ourselves, what we feel for others, and what we do for others. So actual motivation and actions.
So do you think that might make it difficult for some people to empathize? Apparently I can't say this word right. With people who don't experience this type of pain. So for example, some people suffer from frequent headaches or migraines, but if you are a person who never has a headache, like never basically had one in their life, do you think they then have difficulty to empathize with this person?
Yeah, I mean, anecdotally, I can say 100%. I have, for example, never had to deal with migraine, and a lot of my work colleagues have migraine regularly. And it's very hard for me to imagine how horrible it is. I mean, I read about it and I hear about it, and we also test and do experiments with people with migraine. But I think the self experience helps a lot. As women, we know how it feels to have menstrual pain. So that is something that we can experience or empathize with better, maybe, than men. But it could also be that, you can kind of override or add to this self experience by informing yourself, reading about it, trying to understand, asking people, right? So it's not this fixed thing. It's something that we definitely have agency to change.
I was just right now also thinking about if there are any, like, right now this sounds like there are also quite a lot of advantages of being able to empathize with people being in pain, or like to also perceive other people being in pain and imagine how it feels, because then you can maybe be more mindful regarding something or act upon helping them. But like, for me, it seems more plausible that there are quite a lot of advantages in being able to empathize with people's pain. Is that actually the case, that it's more beneficial, or is it rather disadvantaged when you feel that much of the other person's pain yourself that it influences your own acting?
Yeah, I think that's a very thin line. And as empathy researchers, I think we agree that empathy is very important and we need it to interact and communicate with our environment, to understand emotions in general, and to form relationships, be it at work with friends or in romantic relationships, right? So we need these connections and we need to understand how other people are feeling. But of course, it can also be the case that you feel overwhelmed with the emotions of other people. And so a very good example of this is medical professions. So people who have to operate on people every day, they really cannot feel the pain of every person that they have lying on their operating table, or nurses drawing blood every 10 minutes. Some people might be more anxious. So if you as a professional let yourself be influenced too much by this, it may influence your work, right? It may impact your work and also your own well-being. So I think empathy is important, but you have to be very mindful about it. And you have to understand that this is something that can affect you as well. And another example, and I think that's one of the things that made me to not become a psychotherapist, is that as a psychotherapist, you listen to problems and issues people have every day, right? And I think that's also something to be aware of when you go in this direction of profession. You're going to be dealing with a lot of problems, a lot of negative emotions, a lot of issues. So that's also not manageable by some, and that's fine. But yeah, I think it's important generally, but we need to be aware of the power that others' emotions can have on us sometimes.
And also to learn how to not directly cut off, but to distinguish
Regulate it in a way.
situation. Yeah. Makes sense.
And that's where this distinction cognitive affective empathy comes in again. So we can kind of not turn off, but tune down the affective part. So we do not share the, let's say, pain of another person that much, but we can still understand it. So the cognitive part should still be there. There are other situations, for example, in the past, researchers said that people with autism spectrum disorder do not have any empathy. And then later that was corrected because people did more research on this and they found that it's not all empathy. That is, people with autistic people do not have any empathy at all. That is not true. What they found is that people with autism might have specific difficulties with the cognitive part. So taking the perspective of other people and understanding mentally what is going on in somebody else. But what they have no trouble with at all is sharing somebody else's emotion. They might have a harder time understanding what that emotion is, but they are able to share it. So it's not that they don't have any empathy. It is just a different way of empathizing.
You've already talked a bit about placebo, so that you can use a placebo to, you said mainly sugar pills that pretend or tell people that that's a medication, but does it also work the other way around? So kind of I'm playing onto nocebo effect, where you would tell people, well, it's not a painkiller, but actually you're giving them a painkiller. Or are there any ways of measuring that as well and the effect that has?
Yeah, so the nocebo effect is something that has been much less well studied than the placebo effect. I think it's natural because we wanted to start with something that is nice for people. And so placebo effects are benefits, positive effects on the brain and body caused by sham treatments, so treatments that are inactive or don't have pharmacological agents. So that can be a sugar pill, it can be an injection of saline, it can be a plaster that has nothing in it, something like that. But of course, there's also the other side of the coin, and that's we call nocebo effect. So that is any negative effect on the brain and body caused by a sham treatment. So there was a very fascinating experiment that my current supervisor, Ulrike Bingel, did in 2011. And she gave participants the potent painkiller Remifentanyl, that is an opioid. And she actually gave them the painkiller, no placebo this time. But she gave it to participants in 3 different situations, telling them different things about that injection that they were going to get. So in the first part, she told them that that is an injection that will reduce your pain. That is a potent painkiller. That is the positive expectation condition. And then in the second condition, the second time they got it, they were told, now we're going to turn off the injection. So it might actually be that your pain increases again, right? They didn't turn off the injection. In all conditions, they gave the same painkiller to people. And in a third condition, they didn't tell them anything about the injection. They just gave it. And so the fascinating thing is that in the condition where they didn't give them any information, people had an analgesic effect. They felt less pain, and that is the drug effect. So that is what the painkiller should do, right? Reduce people's pain. However, in the positive expectation condition, so where they were told that it's a potent painkiller, the medication worked even better. So people had a higher analgesic effect. So you have the drug effect plus the placebo effect, so the positive expectation on top, making the medication work better. And I don't know if any of you can guess what happened in the negative condition.
Well, quite likely they still felt the pain. Or felt it
Exactly.
again.
So
Yeah.
exactly, in the negative expectation condition, the efficacy of the potent painkiller remifentanyl was nearly gone. So people had basically high pain again. So the medication worked less well than it should have, right? And this study, I think, very elegantly shows the power of expectations and the power of what we think and how that influences how we feel and how we perceive things in the world.
So, for example, if you were in a situation where somebody was in an accident and they need pain medication, they are in the hospital, it would actually be helpful if they were told this is pain medication and this is gonna help you.
Definitely. And the problem is that this is often not done. So if you ask people in the hospital what they're taking every day, they have their little pot with pills and they're like, yeah, the red one maybe reduces my pain and this one is for that. But they don't really know what they're taking or the dosage, for example. And so a big part of what we do at the University Hospital in Essen and with our collaborative research center that is called Treatment Expectation, we try to educate patients to use their expectations to their advantage and ask questions, try to understand what they're taking. And if they have negative expectations, to manage them, to ask yourself, why am I feeling like that? What information do I need to feel better? So that's the one side. And then on the other side, educate medical professionals like doctors, nurses, physiotherapists to communicate better, also to manage expectations in the end. Because what we want is that the patient feels better faster and goes to the doctor less often. And both parties involved need to do their part in order to do that.
So, if I'm in pain, so imagine I'm having a headache, I'm taking an ibuprofen because it's just very bad, so I've decided to take a pain medication. So if I then, while taking the pain medication, imagine that it's going to be very, very helpful for me, it's more likely to actually help me.
I think yes, if you believe that that is true. It could also be, for example, that before you take that ibuprofen, you think about, oh, but Elisa has told me yesterday that she always takes ibuprofen and it never works for her, right? So even unconsciously, you could, even if you take it and you're like, I'm hopeful it will help me, you might still have a negative expectation because you heard it from somebody else or you don't feel well at the moment. It could also be because when the doctor prescribed it to you, he didn't really bring across that it might help you. He could have said something like, "Oh, we're just gonna try that next." So the power of words is also like a really big part of our research to understand what certain things that people say, how that influences people's feelings and perceptions of treatments.
I'm just laughing right now because for me it's super funny. I do struggle with migraines quite badly, and also it started when I was quite young. So, but one person, I'm not gonna drop the name of the medication that person mentioned, but also said, well, that medication doesn't help with migraines. And from that point on, that medication stopped working for me.
Yeah.
And then I started taking another medication. And that's just my migraine medication now. And I'm just using it for migraines because my brain is like, I've just self-conditioned myself that this is my perfect migraine medication because the other one just stopped working at a certain point. That was just while you were talking, I was grinning at myself, thinking like, I've had that. That's
Yeah,
also why I'm not going to
exactly.
name drop anything because I don't want to influence people into anything. But yeah.
No, but I think we should educate people about these effects because that's exactly the point. Everybody of us has experienced expectation effects at some point, but you might not even be aware of it. It might be that you read the package leaflet of your migraine medication and you read about all the side effects from, sometimes headache medications have headache as a side effect or nausea or, other problems. And then the likelihood that you develop these side effects is actually higher. So it can go both ways. It can help you the information that you get or the new framing of a certain medication, but it can also go in the opposite direction and be negative. And it can, in the worst cases, it can even make patients stop taking their medication, which in some cases is really bad.
Just one follow-up question regarding those information leaflets, because I always read them, or at least for new medication, I always at least skim them and want to know what the side effects are, because I want to know what I'm putting into my body at that point.
Yes.
How should people treat those leaflets then if they could negatively influence their side effects?
I think it again varies from person to person. So you might be someone that is very, for you it might be very important to know what you're getting into and to be very prepared, because if you know something, then you can, prepare for it and be aware of certain effects. But for example, me, I would get a little bit anxious if I read about all of these side effects. So I prefer to not read that too much in detail because I know it will affect me. And everybody has to find that out for themselves. On our website that we can link in the notes, treatment-expectation.de, we have a lot of information for patients, how they can, for example, read such a leaflet, how they can prepare for a doctor's visit, or answer questions about placebo effects and expectations. We define a lot of terms. So that's really a nice place to go if you want to understand more about this topic.
Another follow-up question, would this leaflet then kind of act as a nocebo effect?
Yes,
Because
in that case, yes. So I mean, the interesting thing is the leaflet could be leading to a placebo effect if you read it and you're like, oh yeah, it's actually like it seems to be super effective, and it works after 10 minutes already. But it could also be a nocebo effect if you read about all these side effects and then you're just very hopeless and you're like, oh my god, if I develop all of these, how is it ever going to help me? It can go both ways.
I think that's very interesting because I feel like that probably depends on personality type
Yes.
and mood and
Yes.
how you generally feel about life when you come across this leaflet. And
I mean, a very interesting anecdote that I like to tell is that once in my life, I was feeling quite bad and I needed medication, and I knew that a certain type of medication had helped me in the past. And so I felt super bad. I couldn't eat, I couldn't sleep. And I went to the doctor finally, and they prescribed me that medication again. And I had the prescription in my hand. I went out of the doctor's office and I could literally feel my mood improving and my symptoms going away. And and then I went to the pharmacy to pick it up. I didn't take it yet. And I went home and I had some food and I felt better. And that is just to me like the craziest demonstration of expectation effects, because I knew I now have something that will help me. I feel more in control, and that makes me feel better, even though I haven't even taken it yet.
and so the expectation highly influences the outcome.
Yes.
Could some conditions possibly be treated with sugar pills? Like, for example, pain conditions? Because when you have people who experience pain on a regular level, obviously they need treatment, but also a lot of treatment has side effects, which could potentially have negative implications on their life.
Yeah.
Would that be an option, at least for some people?
And that is a very ethical question, right? Because we've been talking a lot about placebos, but in clinical practice, you won't find a doctor prescribing you placebos in secret. So when they prescribe you a medication, you will always get that medication. We do a lot of research on placebos in experiments and studies because that is a controlled environment where people participate voluntarily and we can study that. But there is a new research direction that's been going on for a few years on so-called open label placebos. So these are placebos, but you know about that. So doctors can prescribe you a placebo, but you know that you're taking a placebo. And as you said, I think it could help, for example, chronic pain conditions, but also other conditions, if you take it in addition to your usual medication that has been prescribed, but you want to see if, a positive expectation can boost that effect even more. I think it is a very interesting new avenue to try open label placebos and see if that helps you even more, right? Because it cannot hurt. Worst case, it doesn't get any better. Best case, it gets a little bit better.
I once heard that placebo also works when you know it's placebo. And I think that's a little bit confusing to think about, especially then also with a nocebo effect existing. Do you know anything about that?
Yeah, so that's the whole point of open label placebos, right? So that's the whole notion that you take something, it has no pharmacological ingredient, but your expectation and your, positive thoughts may help to induce actual changes in your body and brain. And of course, that doesn't work for everybody. So there's lots of research on the so-called placebo personality. So people were desperately trying to find out who responds to placebos, who has placebo effects, because those are the people we need to find. And then those are the people that we need to give the placebos, right? Because that works for them. So they have very mixed results. Some of the strongest results are that people who are more optimistic respond better to placebos. People who are less anxious respond better. But there's really not a lot of strong evidence out there for that personality that you need, because there's just so many variables and so many potential traits and states you can have that could influence that, right? So I think the search will probably be ongoing forever to find that personality. For now, we're just trying to see how we can find people who respond well or who can manage their expectations on their own, and then use that systematically for them to feel better.
I think that's all very cool to me. How much
I think so.
Yeah, it's
we can
Definitely is.
influence how we feel, basically, just by our thoughts and having like a positive outlook. Yeah.
Yeah, I think that's the perfect conclusion, no?
Okay, then if there are no more things that you would like to pick back up, which role would you say does cognition play in your research?
I think a huge one. We just spent over an hour talking about the brain and how what we think and expect influences what we feel and perceive, and even our health, and how we act towards other people. So I think that's why we sometimes also call ourselves cognitive neuroscientists, because we're trying to find out what the brain does, and the brain is basically us thinking about things in the world. So I think it's very connected.
And if somebody were to take away like one or two or three main points, what would you say would be the most important information of today?
That's very difficult because we talked about a lot of things. If I just take the last thing we talked about, I would say expectations are powerful. It can go both ways. So think about what your expectations are and whether they're positive or negative, and what you can do to manage them. And next time you see somebody else hitting their elbow or being in pain, maybe you understand a little bit better what goes on in your brain when you empathize with someone.
I think that's the perfect ending. Then thank you for coming to the podcast and talking
Yeah,
to
no
us.
worries.
And
It was really pleasurable and really a lot of information. It was really nice. Thank you so
very
much.
informative.
You've listened to Kaleidoscience, Conversations on Cognitive Science, hosted by Elisa Palme, Sönke Lülf and Sophie Kühne. Produced by Clara Kühne, Imogen Hüsing, Elisa Palme, Leslie Wolk, Sönke Lülf and Sophie Kühne. Produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Luca Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science. This podcast is not sponsored and does not give us any financial profit. If you wish to support us, the most effective way is to do so by leaving us an up to 5-star review on your chosen podcast platform and following us on Instagram. You can reach out to us via mail, comment on YouTube, or message us on Instagram. We are always happy to hear your feedback. Thank you again for listening to us and for your interest in science. If you have any questions regarding this episode or any of our other episodes, feel free to reach out. You can reach out to us via Instagram by sending us a direct message at kaleidoscience_pod or write us an email at kaleidopod@us.de. You can find both links to our Instagram and also the email address in our show notes. We do read all your comments and will also reply to you as soon as we can.